Lesson 1.7 covers the additive rule for probabilities. Recall the following problem. We had this in a previous lesson. You have a bag of marbles that contains 4 red marbles, 6 blue marbles, and 10 yellow marbles. What is the probability of drawing a yellow or a red marble? So the probability of drawing a yellow or a red is the probability of drawing a yellow plus the probability of drawing a red. There were 10 yellow, so I have 10 out of 20, and there were 4 red, so I have 4 out of 20. If I add these and reduce the fraction, I get 7/10. Remember that if our event consisted of 2 or more outcomes that could not occur at the same time, we simply added the probability of each outcome. Well, what if the outcomes could occur at the same time? And before we move on to that next topic, let's look at this next problem to help us understand it. A school's basketball team and soccer teams had a group meeting. All athletes were present. 33 of the athletes played on the basketball team and 25 of the athletes played on the soccer team. There were only 50 athletes in the room. How is this possible? Well, first, let's look. There were 33 athletes that play basketball. There were 25 that play soccer. The problem is, if I add these together, that gives me 58 athletes. But it says there were only 50 athletes in the room. What happened is some of the athletes are playing both sports. And in this case, 8 would play both sports because my sum was 8 over the total. Well, this leads us to the counting formula for 2 sets. And we looked at this in a previous lesson when we were looking at sets. The number of elements in A or B, and that would be the union, A union B, is the number of elements in A plus the number of elements in B minus the number of elements in the intersection A and B. Probabilities follow this same counting principle. We can use the additive rule for probabilities as the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both happening, A and B. This rule reads as the probability of A or B occurring is equal to the probability of A occurring plus the probability of B occurring minus the probability of both A and B occurring at the same time. Let's look at an example. A certain class has 25 students, of which 16 are female, 10 are business majors, and 4 are female business majors. What is the probability that a randomly selected student will either be a female or a business major? So the probability of a female or a business major is equal to the probability of a female plus the probability of a business major minus the probability of both, a female and a business major. Well, there are 16 females out of 25 students, so the probability of a female is 16 out of 25. There are 10 business majors out of 25 students, so plus 10 out of 25. And there were 4 that were both. There were 4 females that were business majors. Well, those 4 females were counted when I found the probability for females, and they were also counted when I found the probability for business majors. So those 4 people have been counted twice, so I need to subtract them out once. If I combine these fractions, I get the probability of a female or a business major is 22 out of 25. On the next example, you randomly draw a card from a standard deck of cards. Find the probability of drawing a 4 or a red card. So the probability of drawing a 4 or a red is the probability of drawing a 4 plus the probability of drawing a red minus the probability of drawing them both at the same time, a card that's a 4 and a red. Well, there's 4 4s in the deck, so the probability of drawing a 4 is 4 out of 52. There are 26 red cards in a deck, so the probability of drawing a red is 26 out of 52. In a deck of cards, there's 2 cards that are red 4s, the 4 of hearts and the 4 of diamonds. Those 2 cards were counted when I counted my 4s, and they were also counted when I counted my red cards. So they've been included twice, so I need to take them out one time. If I add these fractions, I get 28 out of 52, and then reduce that, the probability of drawing a 4 or a red is 7 out of 13. In the next example, you randomly draw a card from a standard deck of cards. Find the probability of drawing a king or a spade. So the probability of drawing a king or a spade is the probability of drawing a king plus the probability of drawing a spade minus the probability of drawing one card that's a king and a spade. Well, a deck of cards has 4 kings, so the probability of drawing a king is 4 out of 52. There are 13 spades, so the probability of drawing a spade is 13 out of 52. There's only one card that's the king of spades. That was counted when I counted my kings and when I counted my spades, so I need to subtract it out once. If I combine and reduce these fractions, I get the probability of drawing a king or a spade is 4 out of 13. Well, in the next example, you randomly draw a card from a standard deck of cards. Find the probability of not drawing a king or a spade. This is an example where I want to use my complements, because to list all the possibilities of not drawing a king or a spade, there's just too many to list. And usually when you see the word not, that's your clue that it's going to be easier to use complements. So the probability of not drawing a king or a spade is 1 minus the probability of drawing a king or a spade. Well, I just found that probability was 4 out of 13. So the probability of not drawing a king or a spade is 1 minus 4/13, which is 9/13. In the next example, you randomly draw a card from a standard deck of cards. Find the probability of drawing a 4 or a 7. So the probability of drawing a 4 or a 7 is the probability of drawing a 4 plus the probability of drawing a 7 minus the probability of drawing both a 4 and a 7. Well, there are 4 4s in the deck, so the probability of drawing a 4 is 4 out of 52. There are also 4 7s in a deck, so the probability of drawing a 7 is 4 out of 52. Now, if I look at a deck of cards, there is no card that is a 4 and a 7. So the probability of drawing a 4 and a 7, that can't happen, so its probability is just 0. So this time I just add the 4 out of 52 to the 4 out of 52 and reduce that, and I get the probability of drawing a 4 or a 7 is 2/13. The events in this last example are mutually exclusive. 2 or more events are mutually exclusive if and only if they have no common outcomes. Or in other words, E and F are mutually exclusive if and only if those events cannot happen at the same time. I could not draw a 4 and a 7 at the same time, so those events were mutually exclusive. When the two events are mutually exclusive, you don't have to have the subtraction part to the additive property. The additive property just becomes the probability of A or B equals the probability of A plus the probability of B. This was the original formula we started with when the events could not happen at the same time. So look at the example. You roll a fair die. Find the probability of rolling a 3 or an even number. Well, I cannot roll a 3 and an even number at the same time, so these are mutually exclusive. So the probability is just the probability of rolling a 3 plus the probability of rolling an even number. Well, if I roll a die, I have 1 3 out of 6 total, so the probability of rolling a 3 is 1/6. There are 3 even numbers, so the probability of rolling an even number is 3/6. If I add these and reduce them, I get the probability of drawing a 3 or an even is 2/3. In the next example, you roll a pair of dice. Find the probability of rolling the sum of a 5 or the sum of an 8. Well, I can't toss a pair of dice and that sum be a 5 and an 8. So these are mutually exclusive. So I just need to find the probability for each one. Let's look at the ways to find the sum of a 5. I could roll a 1 and a 4, or a 4 and a 1. I could roll a 2 and a 3, or a 3 and a 2. Then to find the sum of an 8, I could roll a 2 and a 6, a 6 and a 2. I could roll a 3 5, or I could roll a 5 3, or I could roll both of them as a 4. So there are 4 ways to roll the sum of a 5, and there are 5 ways to roll the sum of an 8. So the probability of rolling the sum of a 5 or an 8 is equal to the probability of rolling the sum of a 5 plus the probability of rolling the sum of an 8. So I have 4 out of 36 plus 5 out of 36. So this gives me, when I add them and reduce, the probability of rolling a sum of either 5 or 8 is 1/4. In the last example, you roll a pair of dice. Find the probability of rolling doubles or the sum of a 6. Let's look at the ways to roll doubles. I could roll 1 1, 2 2, 3 3, 4 4, 5 5, or 6 6. To roll the sum of a 6, I could roll a 1 5 or a 5 1. I could roll a 2 4 or a 4 2, and then I could roll a 3 3. If you notice, these had a common outcome. Rolling the 3 3 is a double and it's the sum of a 6. So these events are not mutually exclusive. They have a common outcome. So when I find the probability, I've got to use the subtraction part. The probability of doubles or the sum of a 6 is equal to the probability of doubles plus the probability of the sum of a 6 minus the probability of both. Well, there are 6 ways to roll doubles out of 36 possible outcomes. There were 5 ways to roll the sum of a 6, so the probability of the sum of a 6 is 5 out of 36. There was 1 outcome that was common to both of them, so I need to subtract 1 out of 36. When I combine these, I get 10 out of 36, which reduces to 5/18. So the probability of rolling doubles or the sum of a 6 is 5/18.